you can go to the Google and type the statulator, and then click on the statulator. This screen will appear. So now you collect on the sample size. Click on the sample size. So this type of screen will appear, and then you go to the sample size here. The first is the estimation of single proportion. So yesterday, I just brief of the yesterday lecture. Yesterday we learned about the prevalence of that. That prevalence, estimation of prevalence for the proportion, estimation of prevalence for the mean, and also the how to calculate the estimation for the sensitivity and specificity and correlation. So this statulator will calculate for the single proportion estimation and for the estimation of mean. So first I will explain about the single proportion estimate, how to estimate your sample size and how to do the adjustment regarding it. So first I will explain this some about this statulator. That screen will appear for the single proportion. So in single proportion there are, you see that first is the calculator is there, and second is visualization, and third is a tabulator. So you can visualize the calculation of the sample size according to the different confidence interval or different proportion, and also it will give the tabular form also. The first value of input, you have to give the level of confidence. This is usually fixed on the 95% confidence level. Then you have to give the expected proportion, but you want to estimate the expected proportion. And then you give to the next is the margin of error. Now margin of error you are giving. In margin of error, we have a two option: margin of error in absolute form and margin of error in the relative form. I have already explained what is that absolute form or what is the relative form. So I am not going to explain here. So this is absolute form or expected form, relative form. If you want to enter the relative expectation of the proportion, then you click on this relative expectation, and if you are taking the absolute, then click on the absolute form. After that, you can press on the calculate. But before this, we need some adjustment for. If you want to some adjustment is there, like we have some discuss about the finite population adjustment and cluster adjustment is there, or continuity correction is there. So in that case, it is available in the adjustment. You click on the adjustment. So this screen will appear. That first is your adjustment to the finite population. If you click on this, it will adjust and ask to the what is your approximately finite population. So I am assuming here the infinite. Just second is the adjustment for clustering. So if you click on this clustering, it will ask two things. Either you put the design effect directly, or you can put the intra-class correlation. If you have an intra-class correlation, then you put the intra-class correlation, and then what is the cluster size. Two information you have to give in the case of intra-class correlation. Or in case of design effect, you just give a one value, either 1.5, 1.75, whatever the design effect you want. This can be, you can write here for the design effect. Then for the adjustment for the response rate. So this is called adjustment for the anticipated response rate. Here you have to put what is your response rate. It is not a non-response rate, it is response rate. Response rate means, suppose non-response rate is 10%, so you have to put your response rate as a 90%, so 0.9. So after that, you click on the update, it will calculate the sample size for your estimation for proportion. So I am now, first of all, I am removing this and update. Now I am taking one example in the from right side, there is a practical examples for the estimation. So first I will take the one example to study the prevalence of poor sleep quality among the adolescent of the urban resettlement colony of New Delhi. So I want to estimate the prevalence of poor sleep. A previous study revealed that the quality among the adolescent of 12 to 17 years is near about 37.6%. Then determine the sample size with 95% confidence level, taking the 4% absolute error. This is, I am taking the 4% as a absolute error. And population of adolescent in this area is 3526. First, I will not considering this finite population. I am assuming for the infinite and calculate the sample size. Then I will go for the adjustment. So here 95, you click on the level of confidence 0.95. Expected proportion we have to change to the 37.6. So here you put the 37. It is a 2 decimal places. So you have to select 38. So 0.38 is my expected prevalence, and then go for the margin of error. Margin of error is absolute form. So I choose as a 0.4. Now I will click on the calculate. So my sample size will be calculate. This result is 566. This is for the without any adjustment. I am not adjusting for the finite population. I am not adjusting for the clustering. I am not adjusting for the non-response. So this is the sample size for 566, assuming infinite population. So I need a 566 subjects to estimate 37.8 or 38% with a absolute precision of 4% either the side. Now I come to the adjustment. I click on adjustment, and then here adjustment is that I have finite population. So I click on the finite population and put value of 3526. This is my finite population given in the question. Okay? I click update this one, and when I update, then automatically this sample size number will change. That is equal to 488. So from infinite 566, my sample size is reduced from to 488. So this is the estimation for the a proportion using this formula. Now we go to the visualization. If you click on the visualization, so here you find this type of graph is there. So it will show the absolute precision on the 2%, 3%, 4%. Not showing the 5%, 4%. It will show the 2%, 2%, 3%, 5%. So in that case, there is a curve is there. You can find out the required sample size based on the your expected proportion. Now, if you click on that tabular form, so when you click on the tabular form, table will appear. So this is our expected proportion it is giving, and there is a absolute precision. This is a different type of different condition. There is a sample size is there. So you can find out from the if this is not adequate. So you have some options for the selecting for the others. Like instead of 0.38, you can check for the what is the 0.31, or here you can change what are the your table form. Minimum is this one, maximum is this one, by this one. So if you want to change into the 0.2, so table will change. So in that case, you can modify your table according to your requirement. Similarly, in the visualization graph, you can change according to your requirement for this. So this is the parameter you have to change for this one to get the visualization. Dr. Dharmender, they are not able to see this one.
Yes, sir. I think it will be better if you can make only one slide, because both the slides are simultaneously
Okay, okay,
creating some problem for the participants.
okay.
So
I will.
once
Now
you
it is okay. Now it is okay.
yes. So participants, you can write in the chat box or you can unmute, because I think this is some hands-on also.
We are able to see, sir.
Okay.
Yes, now it's visible.
Now it's visible. Okay, now.
We
Okay,
are doing simultaneously.
okay,
So please do simultaneously.
okay.
So
So this is the calculated. Now, if you want to adjust this one, another we have adjustment is a finite population. If you adjust for the, if remove the adjustment for the finite population and go for the adjustment of the clustering. So I use take the clustering as a 2. So in that case, I click on update. So my sample size is increased from 566 to 1132. That means a double of my sample size, that is without design effect. That means by default, design effect is equal to, it is 1 URV. Value is 1. Now, if your design effect is 2, it is multiplied by 566 multiplied by 2, that is 1132. Similarly, if you want to adjust for the non-response, so in that case, adjustment for the non-response, I say 10% non-response. So my response is 90%. I update this one. So my sample size will increase for this one. 1 second. 32. Response rate with the this one, there is some error is there. Some anticipated response rate is 0.9. There is some issue is there. 0.9. If you put the 0.1,
Cluster effect is.
there is some problem in there. Acha, cluster I have. Okay. That is cluster. I have to remove that. So if you put here, that is 90.9 and update, your sample size is 6 to 9. From 566, it will increase to the 6 to 9, correcting for the 10% response rate. So these are the information you have to provide for the estimation of a proportion, or these are the adjustment. Now I will explain one more thing to you, that it we have put here absolute precision as a 4%. If you go for the relative precision, then you have to put the relative precision is in the form of percentage. So in the form of percentage is relative. If you are, if there is a 4%, you can see here that what is the absolute precision is that 0.04 multiplied by 0.38. If you click on relative expected proportion, now I am changing this to the 1%. So if you change in the 1% and then calculate, the calculator will show the 0.1 multiplied by 0.38. That is now the relative precision is, my relative precision is, absolute precision is 3.8%. So whenever you are changing from the relative to absolute, the number will change. So if you are wrongly taken as a absolute as a relative, so how much you will change? If I take the 4% as relative, but you have absolute, but you have changed to the relative, in that case, your sample size is how much? 4,352. So instead of 566, it will increase to 4,356. That is because of your wrong entry. So that's why yesterday I told you have to take care about that. It is absolute or it is a relative form while using the calculator. Generally, this type of error will come in that. Now we come to the estimation of sample size for the mean. So click on that estimate of mean. So this this type of screen will appear. You have to put input value, level of confidence is first, 95%. Then you have to enter the what is the your expected standard deviation and what is your precision of error. So in that case, you have to enter the expected standard deviation. I assume that it is a 10 and my precision is margin of error is equal to 1.5. So you calculate according to this information, my sample size is 175. That is assuming the expected population standard deviation is 10 and applying the T distribution to estimate the sample size, the study will require a sample size of 174. So what are the adjustment here? We are assuming the sample size on the base on the formula as a normal distribution, that is a Z value, but it is calculating on the basis of the T distribution. So we go to the adjustment. If we click on the adjustment, if you click on the adjustment, then adjustment for the finite population, adjustment of clustering, adjustment of T distribution. I uncheck this T distribution. So if you calculate the sample size, this is the based on the Z distribution. What is the based on, if you are calculating the formula, you will get value as a 171, or if you adjust based on the T distribution, then your sample size is increased to the 174. So what is the T distribution and what is the normal distribution? In normal distribution, we assume that the standard deviation is known, population standard deviation is known to us. That is our assumption for using the Z normal distribution. For T distribution, we assume that their sample size, standard deviation is unknown, and we are calculating the standard deviation from your sample value. So generally in calculation of sample size, we assume the standard deviation from the previous studies, or also assume that this is our population standard deviation. But if you have a pilot study or some other study, in that case, you calculate the sample size based on your sample. So you can go for the T distribution also. In that case, there is a sample size will increase some marginally increase from 171 to 174. So that is some increase is there. Similarly, if you go to the visualization, then this graph will appear here. The expected standard deviation is this one. Based on the expected standard deviation and based on the precision, what are you taking for the precision? Precision here is, I will tell you, precision is what is the precision from the mean, percentage of mean. No, it is not a percentage of standard deviation. It is a percentage of mean what you are expecting. In estimation of mean, there are two things are required. First is the mean, what is your expected mean, and what is the standard deviation. And margin of error we calculate either in absolute or in relative form. Or what is the percentage of mean or in plus minus mean is required. So in that case, precision is respect of mean, not respect of standard deviation. So here you can change for the expected, if you want to visualize other values. So if here the 5 minimum is 5, maximum is 15, you can change into the 10 to 15, 10 to 20. So graph will change. So here you can have a different type of value according to the standard deviation. If you are not satisfied with your values, you can have another option in your hand. If I can go for this, I can go for this. So there are the various type of option also available that you can say as a sensitivity analysis. I have some other options are available for this one. Again, you can see from the tabulator form also. This value is from the standard deviation 5 and the precision 1.1 based on, you can calculate have a different sample size are there. So this is for the estimation of mean and this is the estimation of proportion. There are two things that we will cover today, and then we will go for the hands-on practice. So I think you understand this, how to calculate the sample size for estimation of proportion or mean. In case you have some problem, you can write in the chat. I will also explain what are the, if you are facing any problem for this. So now another is how to calculate the sensitivity and the correlation for this one. So this statulator is not calculating this correlation and sensitivity. In that case, you have to take you have to take another form. There is a, yesterday I explained the difference between the relative and the absolute. So in that case, I will also explain this one once again, what is the difference between the relative and precision through this slide. I think it is better to explain this slide, relative and so this is what is the meaning of your say relative and absolute. I have explained this. Suppose this is a researcher is want to estimate the proportion of 40%. So in case he select the margin of error, absolute margin of error 8%. So margin of error 8% you are taking. In that case, your 95% confidence level is equal to 32 to 48%. So this is in the absolute form. You directly minus or plus the absolute error into from the 40. But in the case of the relative, you have to calculate the relative error in the k percentage of what is your anticipated proportion. Suppose I have taken the relative precision as a 25%. So it will calculate 25 multiplied by 40. That is equal to 0.1 or 10%. 10% in an absolute form or 25% in a relative form for the anticipated proportion. So this is the difference between the absolute and relative. Similarly, we can calculate for the mean also. If you have a mean 10 and the margin of error 2 absolute, so it will go for the 8 to 12. Or if you are taking the relative precision as a 20% for the mean 10, so it will also 2 plus minus 2. So you can calculate this absolute and relative margin for this one. I think and now you have understand this is what is the difference between the relative and absolute. So I will again this go to the this. So here you have to select absolute and relative. Absolute if you are taking 5%, so our range will be from the 45 to 55. That is 385. You are calculating this one. Absolute form is this. If you are go for the relative form, if relative you select, our absolute is equal to 2.5%. It is also calculating this one. Here calculator shows that 0.5 multiplied by 5, that is a absolute form is 2.5. Our sample size is increased from the 1537. So while entering this absolute or relative, you have to take care about that and see what are you are giving, absolute form you are giving or you are giving for the relative form. So this is for the calculator for the estimation mean and proportion. Now we come to the estimation of the sensitivity and specificity or correlation. For sensitivity, specificity, there is some calculator is available. You can download this calculator from download or you can open that calculator. This is the calculator sample size calculator for the web. So in that case, you can download here. You can see, you can also calculate for the single sensitivity, specificity and the Pearson correlation. So first I will explain for the sensitivity, specificity. You click on sensitivity, specificity and this calculator will appear. So here you have to enter what is your expected sensitivity, what is your expected expected sensitivity, what is expected specificity, prevalence of disease, what is your prevalence of disease is that I have explained yesterday ki what is your prevalence of disease in suspected cases. I emphasize most of the every time that is suspected cases. So you have to enter your prevalence of disease in suspected cases. Then what is the precision plus minus absolute precision? It is asking for the absolute precision, not here relative. It is directly asked for the absolute precision. So plus minus expected, it is showing the plus minus expected. So that means it's asked for the absolute precision. What is the confidence level is 95%. It is asking for the expected dropout. If you have a no dropout, you can put as in initially I am putting no dropout. It is giving the 0. Now my expected sensitivity is 90%. I am assuming that expected sensitivity, specificity is 85%. My prevalence is 20%, and I am taking the precision as a 10%. That means for the both sensitivity and specificity. And then I calculate this one. It will give the sample size based on the sensitivity as 173, based on the specificity as 62. I already explained that the number of disease divided by expected prevalence. So this 173 is divided by number of disease divided by expected proportion, expected prevalence of the cases, and sample size for specificity, you are 62 divided by 1 minus prevalence of expected disease. So whatever value is higher, you have to take here the sample size for your study. Suppose in that case, your sample size is not, you are not taking the only sensitivity is important and specificity is not important for me, and I am calculating the sample size based on the specificity only. So you can put this as a 0. Here you can put as 0, and you can put calculator here. So that gives the sample size as a 173, and for sample size for the specificity is equal to 0. It is not giving the sample size for specificity. If you have a specificity is important for this one, in that case, you put as a specificity as a 0. So you calculate this, sample size will get 62. This is, you can download this software is a from the typing the in a Google sample size calculator for web. So this will a GitHub, this site is appearing, I think, 1 second. You can download for this one from this for sensitivity, specificity, and Pearson correlation. You can download this calculator, and for the estimation of sensitivity, estimation of proportion and mean, there is a statulator.com. You can use that. So this is for the sensitivity and specificity. Now we come to the calculator for the correlation. For if you want to find out the Pearson correlation, then you click on the Pearson correlation. This screen will appear. So I am not calculating for the hypothesis testing. I am going for the this Pearson for the estimation. Today I explained about the hypothesis, but after that we will go and first we will discuss about the Pearson correlation of estimation. So we will give the expected correlation. What is my expected correlation? What is the precision? Here also in the precision in a absolute form, I choose that is equal to precision in my plus minus 0.05. That means my correlation will vary from the 0.25 to 0.35. And what is expected dropout? Dropout, I am clicking as a, there is a no dropout, and calculate the sample size. It will give the sample size for the estimation of correlation between the two variable, that is 1274. So here you can use this calculator to find out the what is the sample size for estimation of a correlation. You can change this correlation to the 4% with the same absolute precision and calculate this one. The sample size will reduce. You can play with the this I think calculating for the different values of this and find out the what is their sample size. So I think you may understand now how to calculate the sample size for the estimation for the sensitivity and specificity. We can discuss, I think if you have any problem in calculating this one, so we can discuss. There is some examples are there. You can try, you can take the screenshot of this and you can try the using this one calculator. This is practical example for the estimation, and this is practical example for the sensitivity specificity. The formula for the correlation I have already explained to you. I think You have not attending the yesterday this one. I have already explained all these things. This is the formula for calculating the estimation of the correlation for the margin of error that I have yesterday I have explained. You can note down that one. This is the formula for this one. So now, Dr. Dharmender, we can proceed for the hypothesis testing or wait for the some queries.
So we can take some queries in
Okay, no problem.
5 minutes, and after that we go for the.
So if any participant has a query related to these two software, so they can ask with it.
Yes, you can unmute yourself. So there are some queries in the chat box also, sir.
1 second, I will see that chat box. No, I think you can not get the PPT, you can get the recording for this one.
Certain variables can be in median.
Pardon?
Certain data can be in median value, no, so instead of mean standard deviation. It is available only in median and interquartile range, the previous study. So
Yes.
how do we calculate?
Today I will explain all these things. In hypothesis, this is I will cover all this one. Today I will explain.
Okay.
Yeah, if you've been any standard deviation is not there, then you how to you find calculate for the median and IQR.
Sir, how do we decide the precision?
Like that precision is decision of the researcher, not the statistician, but basically depends on the, generally we take the precision as a 5% for the, if the prevalence is 10% to 90%, between 10% to 90%. Yesterday I have explained, I think you have attended this one, all about the precision, how to choose the precision. I will also again explain this one. This is the slide for 1 second. How to choose a precision for this one. This is a practical issue. That is what is the appropriate precision for margin of error for the prevalence study. So generally we take a 5% if expected prevalence is lies between 10% to 9%. This is just a rule of thumb, not mandatory for that one, but it is a rule of thumb. You can increase or decrease according to your, you want what is your precision level is there. You can increase to the 10% also. You can increase to the, decrease to the 4% this one. But if your expected prevalence is 10% to 9%, this 5% is not applicable. So in that case, you have to select either based on the relative precision or some expert taking expert opinion on that. But you have to take care what is if you are taking the large precision margin of error, then you have a wider confidence interval. So your reliability is poor. But if you take the small precision margin of error, then your sample size is quite large. Your study may not be feasible for that one. You cannot do for this large number. So choice depends on your researcher to researcher. What is your also depend on the what is the cost is there, what how availability of patient is there. So that also you can consider for that for estimation of the margin, calculating this margin of error. So I think I have answered your query.
Thank you, sir. Thank you.
Sir, sir, there is a question in the chat box.
Yes.
Sir, if the study is cross-sectional study, where we calculate the correlation.
Which one?
Then which formula should we use? Cross-sectional. Rutuparna, you want to ask something?
No, if you don't have a correlation value is there, you have to check for the previous value, previous literature to find out whether calculator is available. Formula, I have you are asking for the formula for calculation of correlation or formula for finding the sample size for correlation. That I have not clear.
So, you showed in the software that for correlation analysis, there is a separate tab where we have to calculate the sample size. So I was asking if the study is cross-sectional study where we have to calculate the correlation, then how we should approach it. Should we go for the cross-sectional section, or we should go for the correlation section?
In there is a no cross sectional, or there is a no. Generally, we find out the correlation in the cross sectional studies. So in observation also, but normally in the 80 to 90% we go for the correlation in the cross-sectional studies. So the formula for finding the sample size for correlation is same. There is no difference between for if you are according to the study design, the formula is this one. You are asking for this formula, just say that you are asking this formula for calculating sample size. This is the
yes, sir.
Yes. This is the
So,
formula.
like for in the cross-sectional studies, we use the 4PQ by D square formula.
No, this is not 4PQ by formula. This is the
Yes, this is for the correlation. So, only for cross-sectional studies, we use that formula.
No, this is not restricted to the cross-sectional, but you can, if you are finding the correlation in the cohort study, you can use the same formula for finding the correlation, but correlation, Pearson correlation. There is no other form correlation like it. If you want to find out the Pearson correlation, it is a Pearson correlation between the two variables. So I have taken the example of the cross-sectional study. You can, if you have a cohort study also, you can calculate, but you are calculating the anticipated correlation. That you have to keep in mind. If I am finding the Pearson correlation or Spearman correlation. No other correlation between the two variables. That one. If you are finding the two correlation based on the chi-square, so that is not applicable here, but you find out the Pearson correlation and the Spearman correlation.
So then where do we use the 4PQ by D square formula?
4PQ, this formula is applicable if you are finding the estimation of prevalence, estimation of proportion. That is a different thing, proportion.
Okay, sir.
And proportion. Okay.
Sir, good evening, sir. Jitesh, want to ask something?
One by one, please ask one by one.
Hello, sir.
Hi.
I have a query. Actually, when we calculate the sample size, taking the absolute error, the sample size comes very small as compared to the use of the relative error. So when it comes in thousands mostly. So my question was that, is there any guideline that when to use the absolute and relative error? Because I was told that when a prevalence is not available, then we take absolute error. Usually we have to take relative error. But in thesis work, if we take the relative error, the sample size comes in thousands, and that is not feasible. So what is, like, I mean to say, when should we use an absolute error and when should we take a relative error?
Absolutely. I have, yesterday I explained this one. If you have your expected prevalence between the 10% to 90%, you can take the absolute error also. But if you have a small expected prevalence, then you take the relative. But one and other are, you can calculate the from relative to absolute or absolute to relative also. So ultimately the value they are interchanging basically. So relative term we generally use if you have a sample size, expected prevalence is a small prevalence for 0 to 10 between that. But if you have a higher expected prevalence, you can go for the absolute. Ultimately, that depends on the what is your margin of error you are deciding. Margin of error, you are deciding what is your, if you are taking the large margin of error, then you have a small sample size. If you are taking a small margin of error, then your sample size is large. So generally, if you take the absolute, so that come a small margin of error. In that case, your sample size is large. So divide what is your confidence interval range for estimated proportion. That is the main thing. If you are estimating the 40% and you are expecting also the margin of my this confidence interval will by 35 to 40. So in that case, you absolute is 5%, or in relative term, you can find out same thing into the, I think 20% or 25% from the relative form. So that you can that depends upon the what is your confidence level you are selecting for this one. I think so.
So that doesn't depend upon the availability of prevalence, because it was told that sometimes when prevalence is not available, then you take the absolute error. It is not like that.
No. If prevalence is not available, another condition, if prevalence is not available, in that case, you expect that your prevalence may be greater than 10% and less than 90%. In that case, you can take your prevalence as a 50%.
Yeah, we can take assume as 50%.
50%, and in 50%, there is a margin of error by default. Rule of thumb is 5% either the side. Or you can take if 10% relative precision, that is also come to the 5%. If you take the life 10% of the 50, that is 5%. Or if you take the 5% absolute margin, that is open. So that vice versa, there you can interchange, you can calculate, but by default 50% you take 5% is it. So it will come 384. But you can increase if you are doing the MD thesis or some small project, you can increase the 5% to 7% or 10%, but you have some justification is there why you are increasing. In that case, your reliability there is a wide confidence interval is there for estimation for proportion, so that the study may be not much reliable. So that you have to take care about that.
So in that case, it is better to take an absolute error rather than taking a relative error with a large confidence interval, right?
No, relative error, not large confidence interval. Relative error, you can take also relative error also. That is also, I say, if you take 5%, that is absolute percent. If you are in, there is a writing term is there. If you say, I have taken the 10% of my expected prevalence, so that is 5% in absolute form.
Okay.
So this is same thing is there. But problem is that if I say 5% absolute margin and 10% relative margin, this is the writing what is changing. But when you have to select the relative is that on the if less than 10% is there, that is in that case you can select the relative margin. Because if you take the absolute margin, that is a higher value. If 10% you are taking 5% minus or 5% absolute or 4%, it is 6 to 14. But if you take the relative as a 10% is a 20%, so that is 2 plus minus 2. Okay, so that is 12 to 14, 8 to 12. Or in the absolute form, generally you take, you will go for the 5%, 4%, 3%. So it will a huge differences there for less than 10 and more than 90%. That you have to take care. That's why we are taking smaller expected prevalence relative in the term. But there is a absolute and a relative. Just a matter of the, I think, word changing is that. How you are writing this one.
Okay, got it, sir. Thank you so much. Thank you.
Hello, sir. If we're calculating the correlation, if we are not getting any previous study citing the correlation, can we do it with the prevalence formula?
This for estimation, generally we consider as a 0.3 as a mild to moderate correlation. So if there no correlation is available for this one, so you can estimate, you can take as a 0.3 or 0.4 for the correlation for this. Below 0.3 is not a correlation.
Sir, for estimating a mean, what is the maximum precision we can take? You told for prevalence studies, sir, for percentages. For estimating mean, what would be the maximum precision we shall keep?
For calculating for the mean, that precision depends on what is the mean value, average value. Suppose if you are taking the systolic blood pressure, your mean systolic blood pressure is 120. So in that precision, you can take 10%, 5% is it. Or suppose you are taking the hemoglobin of that is the range for the 14. So in that case, your precision is depend on the what you are measuring for that one and what is your value.
Is there any maximum percentage of mean we shall keep? Even we shall keep 50% of the mean. Is there any upper cutoff for that?
No, that are known. There is no cutoff for this. 50% of mean that is quite high. You have. So that is a higher margin of error. Generally, we take the 10 to 15%, 10 to 20% of the average mean. What is that 10 to %? So not more than that, not more than that.
Okay, sir. Thank you. Got it.
Yes.
Anybody? Sir, I have a question, sir. Okay, sir, supposing we are taking a non-probability sampling, let's say it is a convenient sampling or snowball sampling, how would it affect our sample size calculations?
That is the sample. This is all our sample size we are calculating based on some probability distribution, not the non-probability distribution. So if you are going for the convenient sampling and the snowball sampling, I calculate the sample size and you cannot not able to get the sample size. So all the basis on the probability. If you are convenient and snowball, so whatever number you are getting, I think with that number you have to take. There is no rule for calculating the sample size for this one, for snowball.
Thank you.
Sir, if you know the total population size, is it mandatory to go for this finite population correction?
No, yesterday I told that if you have if the finite population is less than 10%, 10,000 or 5,000, then you go for the finite population correction. Otherwise, if you think that my study target population is greater than 10,000, so there is no need, there is no much gain for calculating the sample size. There is not much reduction in that. Yesterday I showed that there is I think 2 subjects are there is a reduction is there. So I will show that the one that slide for that where I have calculated this one finite population.
Sir, I think we can move forward.
This is the slide showing the finite correction. So that if you say there are infinite 144 and for finite 10,000 142, but there is not much difference. But if you had a target population is 1,000, so there is a much reduction 126. So that depends on what your finite population is there.
So if population size is less, but in that case also, is it mandatory, sir? Say like my sample is like, population size is 2,000. If I go for that universal thing, the sample size comes like...
It is not mandatory, but I have shown that if you are not able to achieve, if your target population is 2,000 and you have calculated the sample size based on the infinite, you get the 150 sample size. So that is not achievable. You want to reduce. So one method is that you can do the finite population correction. If the sample size will 135 or 130, that may be. So that may be allowed for this.
Thank you, sir.
Sir, in the sensitivity specificity sample size calculation using that app, do we need to divide that value again by prevalence, or that is the final sample size that's being calculated there?
Like in that there is a one second specificity. In that there is sample size with this, like there is no need for it, is already divided with 173.
Okay, so thank you.
Sir, please explain the difference between T distribution and Z distribution.
There are various type of continuous distribution. I know about the statistics. So there is a Z distribution also, T distribution also. Z distribution is both are the if the sample size is large towards the same symmetric, but if a sample size is small, so T distribution is some flat distribution is there, some flatness is there, some wide range. So in that case, if when we use a T distribution, when we use the Z distribution, because T distribution depends on the sample size. So when we know about the standard deviation of our population value that is known to us, in that case we use the Z distribution or normal distribution. But in that case, some cases we don't know about the standard deviation and we determine from your sample as a estimation of standard deviation. In that case, we need the T distribution adjustment. So that depends on where you have taken from your standard deviation or what is your assumption for the standard deviation. If your assumption is that it is a population standard deviation, then there is no need for adjustment. If you say ki we are adjusting for or going for the calculating the standard deviation from the pilot study or some other sources that is not a population standard deviation, in that case you adjust the take the T distribution adjustment.
Okay, thank you, sir.
Okay, now we go for the today hypothesis, or somebody has any question, query regarding this? Dr. Dharmender, can we proceed for the hypothesis?
Yes, sir, we can proceed.
So today we will go for the hypothesis testing. First, we will discuss about the key requirement for the sample size for the hypothesis testing. And then what is the important consideration regarding the sample size for hypothesis testing? Sample size for comparative study with example. Here we will compare one sample mean and one sample proportion with a reference value. Hypothesis testing we use when we are comparing one thing to other thing. Like an estimation, there is a no comparison, but in hypothesis testing is applicable when we are going to compare one value to the another value. So in one sample, also we are comparing with the reference value that is called historical value or historical control value, or what is the literature value. There are some different name is there. So we compare our sample value to the reference value or literature value. In that case, how we calculate the sample size? Sample size for comparing the sensitivity and specificity. Suppose I want to compare the sensitivity and specificity with the literature value. How we calculate? What formula for this one? How we calculate this one? Two independent sample. Now this is for the one sample. Then we go for the two independent sample. Two independent sample mean comparison. In that case, we are having a two parallel group to compare their mean. Similarly, we go for the two independent sample proportion comparison. That is a two proportion comparison, two population proportion. After that, I will explain the some if you don't have a one proportion but you have some relative risk is there or odd ratio is there, then how you can convert your odd ratio into the case proportion or control or case proportion. So in that case, use of odd ratio and relative risk in the estimation of sample size for the two groups in the different case control study or in a cohort study. And lastly, we'll discuss about the sample size for the patient correlation, that we want to compare this one. Now we want compare with the some target value, one population value. We have a given our correlation should be greater than this one. So in that case, what is the how we calculate? Or then we go same thing, we go for the online calculator for finding this one, this Statulator, and the same web calculator for explaining how to calculate the sample size. So these are the 1 second slideshow. So these are the online calculator. Link is there, or you can note down the statulator.com, or this is the vanefrin.github.io for the sample size for sensitivity, specificity, and correlation. So this is the key requirement for in determining the sample size for hypothesis. Some of the I have already explained in the estimation, but I just also explain in the hypothesis testing for the your just recap for this one. So first you define your population. What is your target population? Is this first is your that is going to be inference your study. So that is the defining of the population. Second is there is not a sequence, but I am just explaining one by one. Then you have a study design. So it may be possible first you study design you run, then find a definite defined population. But then you have to go for the study design. What is your study design? You are going for the cross-sectional study design. You are going for the this RCT randomized control trial. You are going for the cohort study. You are going for case control study. So or you are going for the non-experimental trials. So like quasi-experiment or some, there are different type of studies design are there. So you have to design first, because sample size is different for the different study design. So then you have to go for what is your primary outcome is there. Primary outcome, what you are going to be estimate, whether you are comparing the two drug effect, where you are comparing the correlation, where you are finding out the efficacy of this. So that is what is your primary outcome is there. Then what is the type of outcome variable? When you decide your primary outcome, then you decide whether my outcome is a continuous or my outcome is a categorical outcome. So that is depending on your primary outcome. If it is a proportion, then you have to go for the proportion formula. If there is a continuous variable, in that case, you calculate the mean. And if the correlation is their primary outcome, then you go for the correlation, or diagnostic study is there, or some agreement you are going to be find out. In that case, what is your primary outcome, and then what type of outcome variable is you are using for that one, whether continuous or categorical. These are the information you collect before calculating the sample size for this one. But rest of all you have to calculate. But these are the information that you must decide before going for the sample size. Another thing is that what is your variance and what is your clinical important difference. So when you decide your primary outcome, then you search for the or type of variable, then you go for the searching for the literature, whether their study is available or not. Somebody has this same study, some have did, or if you have a two group, one group they have did, another group you are going to be estimate. So you have to go through the literature search, and then you find from the literature search what is the standard deviation. If you found that there is a one group is there or both the groups are there, then okay. If your one group is there, control group there, so in that case you find out what is the standard deviation for your group. So they have mentioned for this one. So this is the main thing for affecting the sample size, that is the standard deviation. Okay, because if you double the standard deviation, your sample size will increase 4 times. So that you have to take care about that. Another thing is that minimum clinically important difference. So that is a minimum clinical important difference is what? If you are comparing one group to another group, what is the clinical value to say one is better than other or one group is significantly different? So that is the main difficulty you are finding. Whenever somebody has come to me for sample size calculation, I ask what is the variance we can find from the previous study. That is no problem. Another is that the clinically important difference. That is when I ask for the clinically important difference, so they are getting confused about that. How we can find out the clinically important distance to the student. Then I say you ask for your guide for this. They will tell what is the clinically important difference, is that how you estimate the clinically important difference. Because if you are taking from the previous study, this difference is available. If you have two groups in the previous study, same study you are going to be repetition. So that clinical difference you cannot take, but you can decide. You can take, but I don't think that is important. You have to decide in your scenario what is the clinically important difference. So there are one or two ways for the finding out. Either your guide will tell what is the clinically important difference. Another is that you can do the pilot study and find out the subject, who the patient, how much, suppose you are estimating for the pain. So if you are giving the one drug, another drug, so patient is response is, what is the response is there, how much I am feeling better. So that may be the clinically important to say one group is another better than another group. So there are some way, or this is some guesswork is there. So that, but it is important for calculating the sample size, minimum clinically important difference. After, if you decide this one, then we go for the either it is direction. Now, what is the meaning of direction and type 1 error and type 2 error? I will explain these in the next slide, but just brief of that. Direction is one-sided direction, or you go for the two-sided direction. If you are saying a hypothesis is that we assume your hypothesis that it will increase in one direction or it will reduce. My new treatment will reduction in the mortality. So I am sure that my new treatment will reduce the mortality or some other treatment benefit, or some, you can say, the pain. In that case, you can go for the one-sided, but you should sure about that it will not increase. And if you have any doubt regarding this, then what you can go for the two-sided. For the safe side, you have to go for the two-sided. If you go one-sided, then ethical committee or some can ask the question why you are going for the one-sided. So better you save, but if you are going for the two-sided, the sample size is large. But if you have a one-sided, the sample size is small for I think 20 to 25% smaller. Then there is a type 1 error and type 2 error. You are committing the two type of error. I will explain next slide, this one, by taking the one example for this. So we are committing in hypothesis one type 1 error. That type 1 error is related to your null hypothesis, and type 2 error is related to your alternative hypothesis. After these values are fixed, type 1 error 5%, and this is type 2 error, we take the 20%, that means power is 80%. So these are the fixed. You can change to the 80 to 90% also. But generally by default, it is a 5% or 80%. Then there is some adjustments are there. Adjustment for the follow-up loss, non-response. Multiple primary outcomes are there. Multiple primary outcomes are what is the multiple primary outcomes? If you have a one primary outcome, there is a no problem. If you have a multiple primary outcome is there, in that case, their adjustment is needed for the multiple primary outcome. Then multiple comparison outcome. Multiple comparison. If you have a more than two groups, that I am not covering here, but only a two groups. If you have a more than two groups, then you have to inflate your sample size. If you are going for the multivariable analysis, then you have to adjust, inflate your sample size accordingly. That I have explained yesterday. If you are going for multiple regression analysis, in that case, you have to take care about the confounding value, how much variable you are including for this one. So this is about the adjustment and the key requirement for this. Now we come to the, again, this is the key requirement, but detailed explanation of the type 1, type 2 error, variability and magnitude and directions. So this is the detail, because these 5 things are important for calculating the sample size. So first, this is the formula for the sample size. You have to variability square multiply by Z value of type 1 error divided by 2. We have taken 2 tail here. Z type 2 error, that is Z beta, or you can take the Z1 minus beta as 80% power, that is square, divided by clinically important difference square. So this is the some standard formula for calculating the sample size. In case of proportion also, in case of mean, I will explain what is the variability in the mean or proportion when we go take the example for the mean and proportion. Now we again come to the what is the meaning of type 1 error. Type 1 error is that probability of rejecting null hypothesis when it is true. That means, what is meaning of that? A new treatment is ineffective compared to the conventional treatment, but researchers say it is effective. Now what is that? That is a error is that. We say ki new treatment is ineffective compared to the conventional treatment, but researchers say it is effective. Our studies showing that there is a significantly different, but in population that is a not effective. In that case, this is called type 1 error. Now the question is how we find out the ineffective in the population. That is our guesswork is there. So that we cannot find out for that. But new treatment is ineffective compared to conventional treatment, but researchers say it is effective. So that is called type 1 error. Type 2 error is that probability of rejecting an alternative hypothesis when it is true. In that case, what happens is that treatment is effective. We are in true population, treatment is effective, but our samples say it is not effective. So that is, there are second type of error. This is belong to alternative hypothesis. Or type 1 error also called a false positive. Level of significance commonly we fix as a 5%, and and we can decrease it to the 1% also. So, or second type 2 error is a false negative error. That is type 2 error usually take 20%, can reduce to the 10%. So why we take the 5% and 10%? That is by default. But most of the studies, 5% false positive is a serious error. False positive is a serious error. Why it is serious error? the researchers say effective, that means your treatment is not effective. Or say if I take antibiotic I am giving, it is not effective in that population, but my study showing it is effective. So that is a serious because it is causing the toxicity for that one. So that's why we are restricted to the 5% error. Second, in the type 2 error is a false negative. That treatment is effective, but the researchers say is ineffective. That antibiotic is usually that in population effective, but our study is showing that it is ineffective. So that maybe if we say ineffective, so some other treatment you can give for the patient. So that is not much serious as compared to the false positive. So we relax to the 20%. This may be sometime may be serious. So we increase to the 90% also, or reduce to the 10%. So that depends on the situation to situation which error is serious for your study. Type 1 error, type 2 error, but 99% the type 1 error is a more serious than the type 2 error. So that's why we are taking 5%, and the type 2 error we are taking usually 20%. So this is the difference for selecting the 5% and 20%. Now the variability I have already explained. The standard deviation is a measure of heterogeneity of variable of interest. This is the what is your standard deviation, what is the variation in the target population. That is called standard deviation, or you can take the standard error also, or in case of proportion, in case of qualitative data. So that is variability. You must know that what is the standard deviation. Another is this is the magnitude of effect, that is called clinically important difference. So this is estimation is by the effect size. Now there is different type of effect size. Our Cohen effect size is there. There are a lot of effect size, standardized effect sizes are there for calculating sample size, but that they may have some drawbacks also. That then difference is directly difference, mean difference is, you can say, a clinical important difference. Association in the case of correlation, risk is there, relative risk. What is the relative risk is there? What is the absolute incidence difference is there? So that is finding out the clinically important difference, or also known as a effect size for that. This clinically important difference or Cohen effect size. This is effect size. Another is a direction for that. Direction is one-sided and two-sided. If you are taking the equality hypothesis, then we go for the two-sided. If you are testing for the non-inferiority, that RCT is non-inferiority trial or superiority trial, then you go for the one-sided direction in that. So these are the 5 parameters is required for calculating the sample size for the hypothesis testing for 2 parallel groups. I want to explain how hypothesis testing, some basic of that. Like estimation, I have explained this one here. What is the background for this? How to calculate this hypothesis testing? So there is some complex procedure is there, but some I think if you understand this one, then you can easily understand what is the concept behind the calculation of the sample size. So I am explaining with one example. 5-year mortality in ovarian cancer receiving the standard treatment is 73% from a hospital experience. See, there is a ovarian cancer 5-year mortality is 73%. And a new treatment, I am planning for the new treatment assessment, and is expected to reduce mortality by 50%. Now, by new treatment, 5-year mortality will reduce to the 50%. So that means 23% reduction, or another way I can say that the 23% is a gain from the 5-year mortality. Now, what is my null hypothesis? My null hypothesis says that there is no difference in the treatment. So there is a hypothesis testing. We have a 2 null hypothesis and alternative hypothesis. Alternative hypothesis is opposite to the null hypothesis. What you are first, you decide your alternative hypothesis, what you want to prove that one from the study, and that reverse is your called null hypothesis. If you want to prove that there is a difference in that, then your null hypothesis is there is no difference. If you find out in RCT there is my new treatment is non-inferior than the standard treatment. In that case, null hypothesis is inferior treatment. So vice versa, if I want to say superiority, null hypothesis is not superior. So alternative hypothesis you first decide, and null hypothesis you are reverse of that. So null hypothesis here is no difference in the treatment. That means our mean difference of 5-year interval is 0. That means mean difference of proportion is 5-year mortality is 0. That means 73% in standard treatment and 73% on average. This is on average basis, 73 in new treatment. Now, I stimulate the 20,000. Hello. I stimulate that 20,000 samples of 100 sample size. So I estimated sample size of 100, 20,000 sample. Assuming that null hypothesis is true. Null hypothesis is true, there is no difference in the treatment, and draw a histogram. This histogram I plot assuming that there is no difference for that. So my mean here is 0 is my mean for this normal distribution, and then I calculate my 95% confidence level. 95% confidence level for assuming the null hypothesis, there is no difference. So it comes to a -13 to +13. That covers the 95% of the area. That means if any of the difference means if any standard difference minus new treatment is between the -13 or +13, that is come by the sampling fluctuation or by chance error. So we say there is no difference for that. This is the area we have here, select 95% confidence in level. That means -13 to +13. Now, if it is go beyond the 13, then we say that the new treatment is somehow beneficial for the standard treatment. Now, I have plotted this one. Now, what second thing, we go for the alternative hypothesis. Now I say ki alternative hypothesis, new treatment achieve 5-year mortality at a difference of 23%. Because I assume that my new treatment will give the average mortality reduction of 23%. So same thing I do here for the 20,000 stimulation of the 100 sample, and my mean is come to be 23. This normal distribution will come to for the alternative hypothesis, and this normal distribution for coming for the null hypothesis. Here I am assuming that there is no difference. Here I am assuming that there is a reduction of the 23%. So that is my alternative hypothesis. Now, this is called the critical value. One critical value I calculate here that depend on the alpha and beta. So according to the 95% confidence, my 13 is that alpha by 2 is 13. So this cutoff is critical value is 13. So left of the side is half of the alpha, like 2.5%. And this is called beta. This is called type 1 error. This is called type 2 error. Because I am expecting this alternative hypothesis, when it is true, then it is type 1 error, that is called alpha. And this is my alternative hypothesis is true, but I am assuming it is false, that is called beta. So this is type 1 error, or this is called type 2 error. This is my power of the study. Whether it is different is actually we get from the treatment or not, that is called, this is our power. So this is concept behind this. We equalize this one and calculate the sample size for finding out the two parallel group. Now, if I increase my sample from 100 sample to the 300 sample, so in that case, what is there? I have more precision is there. So in that case, I got give the large power. I got the large power for that. Or maybe if you see that here there is a overlapping is there, but here there is a less overlapping. So I have a more confident that my treatment is more than equal to 23%. There is a 23% reduction of the on an average 23% reduction. So this is the basic concept for the comparing this one. Type 1 error, type 2 error, and finding out the critical or null hypothesis and alternative hypothesis. So now we come to the commonly used hypothesis testing for the observational study. So these are the, if you are doing the cohort study, that is a common type. Dichotomous is there. Testing statistics is proportion. Null hypothesis, the proportion is equal to this P1 proportion, and alternative hypothesis is not equal to, that may be greater than or less than. If you have a one-sided, this is the two-sided. Similarly, we can cohort study, we can test for the relative risk. Relative risk is equal to 1. Relative risk is not equal to 1. In case control study, dichotomous, if you have dichotomous, then proportion we are comparing, and then odd ratio is 1. This is all for the according to the study design, but the formula is almost similar. In cross-sectional design, the document dichotomous, you have taken the proportion, same proportion formula is there, and if you are going for the continuous, that is the mean, you are comparing the mean for the one group to the another group. Mean with the one mu1, and mean is not equal to mu1. So for the continuous, we are comparing population mean is mu1, and in alternative hypothesis, it is not equal to mu1. So that is the some outcome. What is the testing statistics and relative null hypothesis and alternative hypothesis. So according to the study design. Now, there is a one problem, allocation problem, that is come in usually in the case control study. What happens is that sometimes we have a plenty of controls are available, we don't have a case, or vice versa, we have a case, number of cases are available, but controls are not available. Because some invasive procedure is there, so case will give the blood, but control how to take the blood. So that is the problem is appearing in the case control or in comparative studies also. So what is the solution for that? Solution is that we give the allocation ratio. We select the one cases and two control, or two cases or one control. So I am explaining what is the benefit for cases and control for different allocation. So here, due to the cost, resource treatment, and monitoring side effect, there are some reason for allocation. But if you decided to allocation, that maximum allocation you can go for the 1 to 5. After that, there is a no improvement in the power. So that you have to take care. Ki maximum is equal to one control, or 5 cases, or 5 cases to one control. After that, you don't get any power benefit for that. So but when you are going for the 1 to 5 ratio, then there is a increase in power, but sample size are quite high. So I am explaining by this table, sample size ratio 1:1 ratio is there. The question is that to predict a odd ratio of the two in case of case control study, when the risk factor has a prevalence of 30% with two-sided. So this is my question of the calculating for the sample size for the case control with 80% power, with 5% level of confidence. I am not skipping here. Power I have to calculate. If I have a ratio of 1 to 1, I have 188 subject for the cases, 188 subject for the control. That is 376. My power is 90%. So same thing I have, if I increase the sample size from 1:2, that means 188 to I increase 376. One case, two control, my total sample size will increase to 564, but my power increase from the 90 to 96.37. Similarly, I go for that one. If I have a 1 to 5, then my case is 188, control will 940, sample size is 1128, and you see that 90% into 98.75. So I have a gain of 8.75, but how much sample I have increased for this one. But if you go for the 1 to 6, then there is a sample size increase 188, but power is increasing hardly increasing into the 0.2. So there is a no much increase in the power. So that you have to take care about while allocation ratio. If 1 to 1 ratio, that is good. You get the optimal small sample size. But if you want to go for the 1:2, there is a gain in the power. So according to that, you can decide about the what allocation ratio is. You can go for the allocation ratio. So I think you will understand how we can go for the allocation ratio. Now,
sir, if you don't mind, can I ask you something? Can you go back to the last slide, sir?
Yeah.
So what is the acceptable power, like rule of thumb? It's 95%.
Rule of thumb is 80%.
80%, sir. Okay.
80%.
Thank you, sir.
80. Now, this is the sample size calculation. If you don't have a exact information for the mean or standard deviation, how you get the mean or standard deviation information that somebody has asked for the how to calculate the median and IQR for this one that I have also explained here. If you don't have a insufficient articles are available from the previous study, so then you have a option for the going for the pilot study to estimate the mean and mean or standard deviation. But you have to take care the pilot study should be in a similar fashion where you are going to the planning for the major study, original study, so that you have to take care. Then you go for the expert opinion about the missing information. Amount is missing. If you don't have a mean, then you can go for the expert opinion to find out what is the mean average value, or you can also ask for the what is maybe the tentative standard deviation. But sometime what happen is that you don't have a mean or standard deviation, but you get the median and interquartile. So what is the option for that? One option is that you assume that data is normally distribution, and you can calculate the median, mean and standard deviation for using the median and interquartile range. This is the formula for calculating the mean from median or interquartile. Median is Q2, IQR is Q1 to Q3, that is 25% to 75%. Median is 50%. So mean is what? Q1 plus Q2 plus Q3 divided by 3. You can estimate the mean is this one. And standard deviation, you can calculate Q3 minus Q1, that is called interquartile range, divided by 1.33. But one thing you have to, if you are estimating this sample size from the median or interquartile range, whatever your sample size you get from the this estimate, you inflate the sample size by 10 to 15% to accommodate that median or interquartile estimation. Otherwise, you may not get the adequate result for that. So whenever you are calculating the sample size based on the median or IQR, you have to inflate the sample size for the 10% to 15%. That you have to keep in mind. If you are planning to apply the non-parametric to get the desired level. So whatever is that, because that in literature, it is given the median and IQR. That what meaning of that? It means that the data is not normal. And you will also get your data that is also not normal. Or you will apply your statistical method parameter instead of parameter, non-parameter. So in that, to accommodate non-parameter to get the 80% same desired power, you have to inflate the sample size by 10% to 15%, because if the data is normally distribution, then parameter test needs a larger sample size to get the same desired power as a parameter test. So that's why we inflate the sample size by 10% to 15%. Another option is that you use the Cohen effect size. Cohen effect size is there. There is a ready-made effect size is available. That effect size called small, medium, large for the different type of scenario. If your effect size is 0.2, medium is 0.58, that large is 0.58, that is percentage of control group below the mean of experimental group. So these are the values are there. If relative is effect size is 0, then there is a 50% above, 50% below. If small, These are the percentages there. So effect size, if you are taking small effect size, that your sample size will be large. If you are taking medium sample size, your sample size is greater than small. If you are taking large sample size, then your sample size is greater than medium. So as you increase your effect size, your sample size will be, sample size will be small. I am repeating, a small sample size, you have a large sample size you are required. If your relative sample size is medium, in that case, you need a small sample size as compared to small. So as your effect size are increasing, in that case, your sample size will be small. So these are the to estimate sample size when you don't have some proper information. Now there are some consideration before going for the sample size.
Sir, could you give us the example of the, could you give us example of the, without knowing any of the parameter, mean and estimate, some example, real kind of example, that will be like, give us much more clarity, particularly for me.
No, but suppose you are doing one study for that one. I am not practically that, but hypothetically I can give. Suppose you are doing a one study for that, there is a no previous study you are able to find out. Another thing is that you are doing one treatment, there is a no treatment, earlier treatment is available for that. So in that case, you don't have any values available for that. So you are doing the first time for that one. Or something is, in that scenario, you don't have any information for this. What is the standard deviation is there? What will be the proportion of efficacy is there? So in that case, you have to estimate for that.
So where do we use the Cohen's effect size, sir?
Cohen effect size is another option is there for finding out if you don't have any information. In that case, you can find out based on the effect size they are calculating, but they have a drawback for this one. Because this Cohen effect size is what this Cohen effect size is basically the mean difference of the mean experimental and control divided by the standard deviation. So if these values are there, because it is a ratio, so it is don't have any exact effect size. So that's why it gives a for maybe if you say the 5/2, so suppose 5/10. So that is giving the sample size 5/10 is equal to what? 0.2. That 5/10 is equal to 0.5. Okay. Or suppose difference here is equal to 50/100. So that means also give the 0.5. But here is a 5 mm difference, or that is a 50 mm difference. So in that case, this effect size is Cohen effect size is that ratio according to the standard. What is the variability? But not having the exact value for this. So there is some problem in that. So if you don't have any information, you can take effect size, but I don't recommend for going for this one, for ready-made this one effect size for this one. But they have in literature, it is mentioned, there is a Cohen effect size you can take for the calculating the sample size. The G power is there for calculating this effect size. But if you have a exact mean or standard deviation, then you can find out the exact, or because if you cannot find for the 2.25, if there is small difference 0.2 to 0.5, if my effect size lies between that, then there is a problem is that you cannot calculate the sample size. So I would suggest you to go for the exact calculating the exact effect size if you have a mean or standard deviation for the your outcome variable from the previous study. If you don't have, then there is a problem. Or if you have a one group is there, so you can calculate the you assume their same standard deviation, and what is the clinically important difference you can take from the your point of view, what is the clinically important difference, and then you find out what is your effect size or how much sample size is needed. That I will explain in the how to calculate the sample size. But I don't use the effect size, ready-made effect size. This is called, I say, ready-made effect size. Cohen effect, I in my opinion, it is not good for calculating the sample size.
Thank you, sir. So do we have this session on how to calculate sample size based on Cohen's effect size, sir?
Pardon?
Sir.
Do we have a session on how do we calculate sample size using Cohen's effect size in upcoming slides, sir?
No.
So we haven't had a formula for using effect size calculating the sample.
I am not using the Cohen effect size, but I am using the effect size based on the difference basis, standard deviation or mean difference, clinical important difference. That I prefer this one. But if you want, you can change that formula accordingly. I will explain that one. That I explain to you while I am explaining this mean difference formula for this.
Okay.
Sir, but sir, if we know standard deviation, then we don't need actually effect size. Actually, it is see, this condition is when you don't have any information, standard deviation is not there.
That's I say, if you don't have any information and all these things, then you have an option for going the effect size. But if you have information is with you, then you can calculate your effect size. So that's why I'm saying I am not preferring the effect size. I will not prefer the effect size. I prefer the exact calculation of this one. So in my slides also, I am not explaining the effect size. I am explaining the exact value of it, taking the exact value from the previous study. That known standard deviation. You say known standard deviation or clinical standard deviation. But if you don't have it, you don't have any option. So in that case, you can go. But in my opinion, it is not good for this. This is my personal opinion. Maybe some other have a good argument for this one. But my personal opinion, I never calculate the sample size based on the effect size. But I have seen in literature, they have calculated the sample size based on the effect size.
But sir, if standard deviation is not available, you cannot have the effect size also, no? Because the formula requires standard deviation.
No, you don't. This formula is required standard deviation to calculate the effect size. But these are the ready-made effect size are available. Like in proportion, you say estimate and you take the 50% as a by default, it is give the maximum. So here they give the ready-made effect size. Okay. There is no need for the mean and standard deviation. You just put the effect size in that sample size formula. It will calculate the sample size. But it is ready-made. You can say, ready-made there. If you are nothing is available, then you go for this.
Okay.
So, sir, how can you find out the effect size, like 0.2 when we applied for that thing?
You can calculate the effect size by using this one mean of experimental group, mean in control group divided by standard deviation. This is the effect size formula for this one. But if you have a information, you can calculate the effect size, but or same information you can put in the formula. I will explain the sample size formula, then you can understand the what is effect size. And this is the next slide. I am explaining this one. You just remember that effect size is equal to difference in mean divided by standard deviation. You just remember that one. Okay.
Okay.
Excuse me, sir. Sir, standard deviation of which group is taken? Experimental group or control group?
Generally, we assume that both standard deviation are similar. But if you have a different standard deviation, there is a formula is for assuming taking the different standard deviation is there. But generally, what happens is that if you are doing some experiment, you know the standard deviation of one group, another group, because you have not done, you are doing the experiment, you are don't know about the standard deviation of other group. So you assume that it is equal to the similar group.
But sir, if the standard deviation differs, say in one group it is more and in one group it is less, then the problem arises.
I will explain in the next slide how to calculate this one.
Okay, sir. Okay. Thank you, sir.
I will explain. So these are some important consideration regarding the sample size. I think I have already explained all these things are there. You increase the sample size if you are using the some pilot studies there. Another important factor is or clinical important different. the clinical important difference. I will read out this one. The main factor that influencing the sample size calculation is the standardization for the continuous and proportion for the binary. These are some previous studies or pilot study. The prior study may or may not be exactly applicable to the actual situation. If you are calculating the sample size based on the prior standardization or this one, they may not applicable. So safe sound, you increase your sample size by 10%. This is your optional, whether you want to increase or you don't want to increase. But this is the suggestion is there. Another important factor is the effect size or clinically important difference. Should be biologically or clinical sense. That effect size, but are clinically important difference you are taking, that should be biologically or clinically sense only. Because you are taking the effect size to decrease the sample size, that may not be good for that. Because suppose I increase the sample size, I increase my clinically important difference to get the small sample size, but that is not feasible. So you don't get the result. Generally, this will happen in doing the MD thesis and all these things. They know they want small sample size, so what they increase the clinically important difference to get the small sample size. So that should be biologically or clinically sense in that case. Sample size formula is based on the Gaussian sampling normal distribution, and the sampling scheme is a sampling random sample. We are assuming that their data is coming from as a random sampling. The adjustment will be needed if you are sampling distribution is not Gaussian. If you are doing the cluster, you have to adjust this one. Recommended type of error is 5%, and for type 1 error, type 2 error is 20%. But if you can change accordingly, depending on the consequences for that. Another is that sometimes data is skewed, that I have already explained the mean or how to convert into the median, and there is a need for checking the assumption associated with the formula when the sample size is calculated by online website or formula. For example, I am saying you have to check the assumption. Assumption is what they are using the T distribution or they are using Z distribution. This formula assumption is you have to check whether they are taking the null hypothesis assumption equal as alternative assumption for the proportion. So that's assumptions you have to check what assumption they are using in their formula. In case of proportion, the sample size is determining using the normal distribution, a binomial one. So I have explained what is the continuity correction is there yesterday. So you can do for the continuity correction. There is one thing is that sample size is not necessary for every study. There is no necessary to calculate the average sample size for every study, but the justification is needed. You have to justification for why you are not calculating the sample size or why you are taking this sample size for your study. So this justification is required for sample size. Now we come to the formula for the calculating the sample size for comparing the mean with a known value. This is sample size calculation, one group sample size calculation. We compare this value with the literature value. So we have in that case, we have only one group. We draw a sample and calculate the mean, and this mean we compare what we mean compare with the literature value of. So I will explain. This is the formula first from a null hypothesis. First I will take the this null hypothesis is that my sample mean is equal to my reference mean. That is called the reference mean. Or in that case, alternative is that my sample mean is not equal to reference mean. Some other value is there. So what is expected average mean of test population? And this is the expected average in the control population or the literature value. That is the this value we assume from the literature. We don't take the sample for calculating this one. So this is the one sample analysis for this, comparing the historical value. So I am taking one. This is generally not doing in the medical studies, but somehow some in case of the RCT or some phase 1 trials, we generally do that. We cannot take the control group. So we compare with the literature value. An investigator want to assess the average value. first I explain the sample size formula. Sample size formula is this standard deviation square. Standard deviation square is your sample standard deviation. And this is equal to Z1 minus alpha by 2 plus Z1 minus beta square. And this is equal to mu1 mean square minus mu2 square. Now if somebody has asked me this one effect size, so I ask you to remember that this is the difference of mean divided by standard deviation. Now, if I divide this standard deviation to here, so this will affect your effect size. Understand this one? If I rho squared I divide here, so this portion will become my effect size. So in that case, you can put the value of effect size also in this formula. So an investigator want to assess now this is the example. An investigator want to assess the average weight of mean over the 55 year of age with the newly diagnosed heart disease in Delhi, and literature values show that the average weight of newly diagnosed heart disease over the 55 year of man is nearly 80 kg and the standard deviation is a 20 kg. The average weight is considered different than the literature value when the difference of average weight is 10 kg. I say if it is lesser than the 10 kg or more than 10 kg, then I consider as a significant. So my clinically important difference here as a 10 kg, how many sample would be needed for 5% level of significance with 80% power? So I substitute this value at 5% level of significance. Z value is that I explained yesterday 1.96, and for the 80% power, 90% power, value of Z is equal to 1.28. That I square here. Standard deviation is 20 square, and the difference of the mean clinical is 10 per square. That is plus this addition you have to add for the formula 3.84, that is the Z square 1 minus alpha 1.96 square divided by 2, that give your sample size as a 45 subjects is needed. So to prove this one sample, say ki our in heart disease that average weight is less than or more than 10% as compared to the average 90 kg, we need a 45 subjects with 5% level of significance and 90% power of this. Now, this is the sample size formula for the comparing the two independent group. Two independent group, that if you have two groups for comparing this, or you are taking the two group you are in your study and collecting the data for the two groups. So in that case, null hypothesis is equal to there is a no difference between the two means. That means there is a no difference between the two treatment. And alternative hypothesis is that there is a difference between the two treatment is there. So this formula is there. Here I am taking that standard deviation of A, standard deviation of B. Here, if you have two different standard deviation for two different population, you can use this formula for calculating the sample size. Here it is covering both the standard deviation for one population and the another population. Same, this is the Z1 minus alpha by 2 plus Z1 1 minus beta. This is my clinically important difference. So clinically important difference is that this is the mu1, mu A minus mu B difference is there. What is the, if it is not equal to 0, an alternative hypothesis, if it is not equal to 0, then what? It may be some value that is called clinically important difference, or we say as a delta value for clinically important difference. So this is equal to mu, delta is equal to mu A, yani ki mean of one A population minus mean of B population square that. So this formula for calculating the sample size for the two mean. If you have assume that both the groups are equal mean, so this formula is reduced to the this formula is reduced to the this format 2 multiplied by standard deviation square multiplied by Z1 minus alpha by 2 plus Z1 minus beta divided by a clinical important difference. So that is the formula for the unequal variance. This is the formula for equal variance. I am taking this example for calculating the sample size. This example is that suppose a difference of at least 1 gram in hemoglobin is considered clinically important difference between the two patients receiving the chemotherapy and the patient receiving the chemotherapy plus radiotherapy. Here that there are two groups. One group is receiving the chemotherapy, another is receiving the chemotherapy plus radiotherapy. The previous study suggests that the SG of HB in the chemotherapy is 2 gram per deciliter and in the CT plus RT is equal to 2.0. That means both the group standard deviation is equal. The researcher wished to detect a 1 gram per deciliter as a clinically important difference with 80% power. What sample size would be adequate if the level of significance is 5% and we are equal allocation in both the groups. So this is my question is that I am assessing whether the hemoglobin level after chemotherapy and the chemotherapy radiotherapy is different or not, and my clinically important difference is 1 gram. Then I use this formula for calculating this equal variance formula for calculating the sample size. That is 2 multiplied by standard deviation square plus Z1 minus alpha by 2 plus Z1 minus beta square divided by your clinically important difference. Clinically important difference is 1 gram per deciliter. Standard deviation is 2 square, that is 4, multiplied by 2, that is Z alpha by 1.96 and 80% power 0.842. That gives the sample size of 63 subjects. So for comparing this, you can calculate sample size for the comparing two group with this formula for equal mean, or if you have an unequal mean, in that case, you can say population mean standard deviation of one group plus population standard deviation of second group divided by clinical important difference. Rest of the things are same. Hope now we come to the sample size determination for the population proportion when compared to the historical control. So this is the formula for calculating the population proportion of the historical control. One null hypothesis that my proportion is equal to this hypothetic control population, and
Sir?
alternative hypothesis is not equal to yes.
Sir, one.
Pardon?
Sir, one query regarding the previous slide.
Okay, actually, can we discuss in the last?
Okay, sir. Okay.
After finishing this one.
So once we complete the session, after that we will take the questions.
Okay, sir. Sure.
So this is the sample size determination for population proportion when compared to the historical control population. My null hypothesis is that there is a sample proportion is equal to control population or hypothetical population, or alternative hypothesis is not equal to. So this is the formula for calculating this. I am not going to explain here. The P0 is equal to my historical population, and pi A is equal to my alternative hypothesis, that is pi 1. So we substitute all these value and you get the sample size that is needed for this one sample population comparison. I will explain with the one example for this one. That is a better way for this. Suppose a rate of wound infection over the 1 year in open theater was 10%. So this is our 10% we are giving for the Amara historical population from this is percentage of the 1 year from the hospital record. And I want to confirm that whether a new this figure confirmed by the several other operating theaters with the same scrub up preparation. So there are other things are same and also confirmed by the some other theaters also the 10%. if the investigator wish to test the efficacy of a new scrap up preparation, whether it is 10% or no, so how many operation does it need to examine 90% power and 5% level of significance that this new scrap preparation will produce only 5% infection rate. So that means I assume that there is a 5% infection rate. Here the infection rate is 10%, and I assume that it will reduce to the 5%. So what is our null hypothesis historical is equal to 10%. My alternative hypothesis is equal to 5%. And here I am saying, assuming that it will, the new method will not increase the infection rate, but it will decrease the infection rate. So that's why I am taking the one-sided instead of two-sided. So my alpha is equal to 0.05. At 0.05, one-sided value is equal to 1.645. And this formula I have applying 10% multiplied by 1.0.10 plus 90% power. Z value is equal to 1.28 and infection rate is 0.05 plus multiply by 1 minus 0.05 square, that is, or this is the clinically important difference, is equal to from 10% to 5%, there 5% reduction to 0.05. Substituting in that, I will get the sample size of 239. 239 operation I will need to prove that there is a reduction of 5% with 90% power and 5% level of significance. So this is the one sample proportion comparison. Now the formula for comparing the two proportion, it is if you have a two proportion, then this is formula we use to compare. Here the null hypothesis is that there is a no difference in the proportion, and alternative hypothesis is that there is a significant difference in the proportion. So this formula is for the two groups. We take the Z1 minus alpha, and this is the 2 pi bar. 2 pi bar, what is the 2 pi bar? 2 pi bar is equal to sum of one proportion plus two proportion divided by 2. And alternative, plus Z1 minus beta is equal to square root of pi 1 minus pi plus pi 2, 1 minus pi 2 divided by clinically important difference, that is equal to pi 1 minus pi 2. So what is, how you assume that in your alternative hypothesis, this pi 2, pi 1 you known to, this is the proportion in the control group is there, and I am doing the treatment group, and this is my clinically important difference. Suppose 10% you are taking and 10% infection rate is pi 1, and now I am taking 5% reduction. So my pi 2 is equal to 5%. So this is my hypothesis. Or if I say 10%, I have a 90% my success rate is that, and I am increasing the 5% more success rate, that is 95%. In that case, in the new treatment, it is 95% success rate. So the plus and minus, depending on that, is you are going to be success, there is adverse effect or there is a benefited effect. So according to your hypothesis will change for this. And this is example for two sample t-test, two sample proportion. Investigator plan is study with a 1:1 ratio. There is a 1:1 ratio I am taking to evaluate the thyroid status of the diabetic and non-diabetic. The thyroid status is divided into the only normal and abnormal categories, but under the very stringent criteria. The objective is to assess whether there is association between the thyroid status and diabetic. So the anticipated proportion of the abnormal thyroid among the control is 15%, and how many subject group needed with the 80% power and 5% level of significance to detect a difference of at least 10%. So here I am, my thyroid is 15%, or in diabetic group, I am expected that it will increase to the thyroid status. That means from 15% to 25%. Thyroid is non-diabetic 15% and abnormal thyroid I am suspected that it will increase. So this is the 15% to 10%, that is 25%. I will calculate the average of this 25% to 15%, 0.25 plus 0.15 divided by 2, my this is equal to 0.20. I substitute this value in this formula and get the sample size for the 251. So 251 cases and 251 controls are here, or 251 non-diabetic and 251 diabetic subjects are needed for finding this one. So now